and I'm a professor of neurobiology and ophthalmology at Stanford School of Medicine. This podcast is separate from my teaching and research roles at Stanford. It is, however, part of my desire and effort to bring zero cost to consumer information about science and science-related tools to the general public. Today's episode is going to be all about vision and eyesight, a topic that's very near and dear to my heart because it's the one that I've been focusing on for well over 25 years of my career. When we hear the word vision, we most often think about eyesight, or our ability to perceive shapes and objects and faces and colors. However, our eyes are responsible for much more than that, including our mood, our level of alertness, and all of that is included in what we call vision. What is vision? Well, vision starts with the eyes. We have what's called extraocular light perception. While it feels good to have light on our skin, while it feels good to be outside in the sunlight for most people, the only way that light information can get to the cells of your body is through these two little goodies on the front of your face. And for those of you listening, I'm just pointing to my eyes. As many of you have heard me say before on this and other podcasts, your eyes, in particular your neural retinas, are part of your central nervous system. They are part of your brain. They are the only part of your brain that sits outside the cranial vault. In other words, you have two pieces of your brain that deliberately got squeezed out of the skull during development and placed in these things we call eye sockets. Now, the eyes have a lot of other goodies in them that are very important, and those are the goodies that we're going to focus on a lot today. There's a lens to focus light precisely to the retina. There are also other pieces of the eye that are designed to keep the eye lubricated. You also have these things that we call eyelashes. Most people don't know this, but eyelashes are there to trigger the blink reflex. They aren't just aesthetically nice. Eyelashes are there so that if a piece of dust or something starts to head towards the cornea, the eye blinks very, very fast. It's the fastest reflex you own. We also have these things called eyelids. Now, eyelids might seem like the most boring topic of all, but they are incredibly fascinating. Today, we're going to talk about how you can actually use your visual system to increase your levels of alertness based on the neural circuits that link your brainstem with your eyelids. So, let's talk about what the eyes do for vision. Basically, the entire job of the eyes is to collect light information and send it off to the rest of the brain in a form that the brain can understand. Remember, no light actually gets in past those neural retinas. It gets to the neural retina, and we have specific cells in the eye called photoreceptors. They come in two different types, rods and cones. Cones are mainly responsible for daytime vision, and the rods are mainly responsible for vision at night or under low light conditions, generally speaking. These photoreceptors, the rods and cones, have chemical reactions inside them that involve things like vitamin A, and that chemical reaction converts the light into electricity. Within the eye, within the retina, there are then a series of stages of processing, and that information eventually gets sent into the brain by a very specific class of neurons. They're called retinal ganglion cells. Now, here's what's incredible. I just want you to ponder this for a second. This still blows my mind. Everything you see around you, you're not actually seeing those objects directly. What you're doing is you're making a best guess about what's there based on the pattern of electricity that arrives in your brain. Now, that might just seem totally wild and hard to wrap your head around, but think about it this way, because this is the way it actually works. Let's take an example of a color like green or blue. You have cones in your eye that respond best to the wavelength of light that is reflected off, say, a green apple. So you don't actually see the green apple. What you see is the light bouncing off that green apple, and it goes into your eye, and you see it and perceive it as round and green, but not because you see anything green. No green light arrives in your brain. What happens is your brain actually compares the amount of green reflection coming off that apple to the amount of red and blue around it. What the brain is receiving is a series of signals, electrical signals, and it's comparing electrical signals in order to come up with what we call these perceptions, like I see something green, a green apple, or I see red. So that's what I'd like you to understand about the way the eye communicates with the brain. I would also like you to understand that the brain itself is making these guesses, and that those guesses are largely right. How do I know that? Well, they're right because when you reach out to grab a glass, most of the time you grab the glass and you don't miss, right? Most of the time when you make judgments about the world around you based on your visual impression of them, it allows you to move functionally through the world. So the brain is doing these incredible things. It's also creating depth, a sense of depth, even though what arrives from the retina is essentially a readout of a two-dimensional flat image. Your eyes are slightly offset from one another so that, for instance, if I look at you, if you were standing right in front of me right now and I were to look at you, the image of your face, the light bouncing off your face, to be more precise, lands on one eye in a slightly different location than it does in the other eye, and then the brain does math. It basically does the equivalent of geometry and trigonometry and essentially figures out how far away you are from me, which is just incredible. So the brain does all this very, very fast, and the brain uses about 40 to 50% of its total real estate for vision. That's how important vision is. Now I want to talk about the other aspect of vision, which is the stuff that you don't perceive, the subconscious stuff. And then we'll transition directly into how you can use light and eyesight to control this other stuff, because it's very important. And that other stuff is mood, sleep, and appetite. And there are ways in which you can use these same protocols that I will describe in order to preserve and even enhance your vision, your ability to see things and consciously perceive them. So the protocols we will describe have a lot of carryover to both conscious eyesight and to these subconscious aspects of vision. And I just want you to understand a little bit more about the science of seeing, of eyesight and vision, and then all the protocols will make perfect sense. So as amazing as eyesight is, it actually did not evolve for us to see shapes and colors and motion and form. The most ancient cells in our eyes, and the reason we have eyes, is to communicate information about time of day to the rest of the brain and body. Remember, there's no extraocular photoreception. There's no way for light information to get to all the cells of your body. But every cell in your body needs to know if it's night or day. Now, I talked a little bit about this in the episodes on sleep, and this episode is not about sleep. But I want to emphasize that there is a particular category of retinal ganglion cell. Remember the neurons that connect the retina to the brain. These are so-called melanopsin retinal ganglion cells, named after the